Alright, so here is a typical plane geometry complex number problem. On the Argand diagram, the points A1 and A2 correspond to the distinct complex numbers U1 and U2 respectively. Let P be a point corresponding to a third complex number Z. Points B1 and B2 are positioned so that triangle A1PB1 and A2B2P, labelled in an anti-clockwise direction, are right-angled and isosceles with right angles at A1 and A2 respectively. The complex numbers W1 and W2 correspond to B1 and B2 respectively. Alright, so explain why W1 is equal to U1 plus I outside of Z minus U1. That's the first question. And for the second question, find the locus of the midpoint of B1, B2 as P varies. Okay, so this question sounded like a mouthful, but it is actually really a lot easier than it seems. What I don't like, however, is they've unnecessarily used two different notations to describe the same thing. Okay, so they've expressed this variable point here as the point P, but it's also the point Z as well. So it just adds a layer of confusion into the whole process, but let's persist. So for the first question, if I construct a vector from the origin to the point Z, and I also construct a vector from the origin to point A1 or U1, then the vector pointing from A1 to P or U1 to Z, the cyan coloured vector, is Z minus U1. So this is simply a result of vector subtraction, where I'm subtracting this green vector from the purple vector, and I'll switch them off now for clarity. Now the vector that points from U1 to W1, because it is angled at 90 degrees to the cyan vector, Z minus U1, this vector then is simply equal to I times Z minus U1, because multiplying by I will give me a rotation of 90 degrees on the complex plane. And again, by vector subtraction, if I construct a vector from the origin to U1 and I construct another vector from the origin to W1, this purple or magenta vector is also equal to W1 minus U1. So for the first question, we have W1 minus U1 is equal to I outside of Z minus U1. And then I simply rearrange this equation to get W1 is equal to U1 plus I outside of Z minus U1. And for the second question, find the locus of the midpoint of B1, B2 as P varies. Well, from the first part, this is an expression for the point B1. Now we need to find an expression for the point B2. And we follow exactly the same process as we did before. So if I draw on my diagram again, Z minus U2 can be represented by this long cyan vector that I'm drawing now. So this is Z minus U2. And to get this vector, which is W2 minus U2, what I do is simply multiply Z minus U2 by negative I. So positive I multiplication is a rotation in the anti-clockwise direction by 90 degrees, and multiplication by negative I is a rotation by 90 degrees in the clockwise direction. Sorry, did I say counterclockwise or clockwise for this multiplication? I meant counterclockwise. So the expression for B2 is W2 minus U2 is equal to minus I outside of Z minus U2. So that implies then that W2 is equal to U2 minus I outside of Z minus U2. And this of course is our expression for the point B2. So now the midpoint between B1 and B2, this can be found by taking the average of W1 plus W2. So a half of W1 plus W2. So a half of W1 plus W2 is equal to a half outside of U1 plus I times Z minus U1 plus U2 minus I times Z minus U2. So let's simplify this. So we get a half outside of U1 plus IZ minus IU1 plus U2 minus IZ plus IU2. And since we've got a plus IZ and a minus IZ, these cancel. So what we have is a half outside of U1 plus U2 and then plus I outside of U2 minus U1. So this is the locus of the midpoint between B1 and B2, or W1 and W2. As you can see, it is independent of the variable point Z, so therefore it is a fixed point. And that's a very interesting result, but it sort of makes sense too, because if I relocate the point Z to here, then my geometry changes to something like this. So this is Z minus U1. And this is Z minus U2. And the new W2 then gets relocated to about here. And to complete the two triangles, I'll draw in their longer sides. But the point between them will be a fixed point if I've drawn my triangles accurately enough, which I probably haven't. Alright, so I hope this video has helped you better to understand plane geometry problems involving complex numbers. Please give me a like and please subscribe to my channel for more free math tutorials. In the meantime, best of luck with your studies and I'll see you next time.